In this lesson, we are going to look at the introduction to quadratic functions. Now, a quadratic function is a function of the form f of x is equal to a squared plus bx plus c, where a, b, and c are constants. Now, here a quadratic function, whenever you see a function where the x is raised to the power 2 or the highest, greatest exponent raised to a given letter is 2, that is what we call a quadratic function. Now from there, we need also to know that quadratic functions has some graphs that we need to know, and the shape of the graph depends on the sign of this number here, which is our a. So if a is positive, it has its own shape, while if a is negative, also it has its own shape. So now here what you are saying is a quadratic function may form a shape that opens upward. It may also form a shape that opens downward. Now the graph of a quadratic function, this shape that I've drawn, this is what we call now a parabola. So the parabola is just the graph of a quadratic function. Now let's look at the first part here. So the first part, this shape of our parabola, this one is known as a small shape. Then for this one here, this is what we call a frown shape. So the shape of a parabola may be a small or a frown shape, depends on the value of a. Now for us to have the small shape, for us to give us the small shape, the value of a must be positive. Then for us to get the frown shape, the value of a must be a negative. So whenever you see a negative number in front of x squared, simply means the shape that function will form will be a frowny shape. Now from there also, there are other basics that we need to know about these two shapes here. There is a vertical line that we can draw that passes through the turning point of each. So here also we have this vertical line in dotted lines. Now this line is known as axis of symmetry, and sometimes you may be asked to find the coordinate of axis of symmetry. So axis of symmetry is just a vertical line that passes through the turning point of a parabola. And also here we have this, what we are referring to as axis of symmetry. Now from there also, the other point that we need to know is this point where we have the turning point. So this point is what we call the turning point of a parabola. So even here, so regardless of the shape that you have, any shape must have the turning point. Now the turning point is given in form of coordinates, and sometimes you may encounter a question where you are asked to find the coordinates of the turning point. So the turning point must be in x, y coordinate here. So also we are saying that should be in x, y coordinate. Then from there, turning point, the definition for the turning point, this is just the point where a parabola turns. Now the other part that we need to know for each given shape here, we need to know that when we have a small shape, the value, this value is what we call the minimum value. So we have the minimum value here, and the minimum value is given by the y coordinate of the turning point. Then for the frown shape here, we are going to have a maximum value. So whether a minimum or maximum, each value is given by the y-coordinate of the turning point. So after calculating the coordinates of the turning point, the y-coordinate represents the minimum or the maximum point. It depends on the given question. Then for the x-coordinate represents the axis of symmetry. Now from there, let's look at the two formulas that we use whenever we are finding the turning points. So the turning point, the x-coordinate is given by negative b over 2a. So this is the formula for the x. Now for the y-coordinate is given by 4ac minus b squared over 4a. So these are the formula that we use as long as we are dealing with the turning point. Okay, now let's have an example. Okay, now we have the first example here. Now first let's write the function. Now after that, let's now identify the values of a. So we know from the quadratic equation or function that the value of a is the number from the x squared, then b is the coefficient of x raised to the power 1, then our c is constant. So from there we can see that our a is equal to positive 2, our b is equal to positive 4, our c is equal to negative 5. Now the first question, our question A, we want to find or tell from the given values the type of the shape a given function or form. So we can have this question where will this function form a smile or frown shape? So what type of a shape is this function will give us if we are to plot this function. Now so here I want us we look at how do we identify the type of the shape that the function can form just by looking at the numbers. So here the important part that you are supposed to look at is the sign of the value of a. So regardless of this number, what you just have to focus is the a positive or negative. So we can see that the value of a is positive, so it is going to give us a small shape. So here we are going to have a small shape since the value of a is positive. So we can say this will form a small shape. So this will form a small shape because the value of a is positive. So whenever you see the value of a has a positive sign, you can conclude by saying the shape that function can form is a small shapes. Now from there we can move on to question B. Now question B also, this function have a minimum or maximum value. So since we have this small shape has a minimum value, or what we can say is we can say this function will have a minimum value because the value of a is positive. So we can identify the type of the shape and also the type of the value that a particular function can give us depending on the sign of a. So if a is positive, we have a small shape and a minimum value. while if a is negative, we have a frown shape and a maximum value. Then from there, we can now move on to question C. Now, question C here, we are trying to find the coordinates of the turning point. So now, when finding the coordinates of the turning point, we need to find the x coordinate and the y coordinate. So now let's begin by finding the x coordinate. So we say the formula is equal to negative b over 2a. So from there we can now substitute. We know that b is equal to 4. So we have 4 over 2. Our a is equal to positive 2. So we can now simplify. We have negative 4 over 2 times 2. We get our 4. X is equal to negative 1. So the turning point of this function for x is negative 1. Now let's also check for the y coordinate. So for the y coordinate, there are two ways in which we can find the y coordinates. First, let's find this y coordinate using the formula. So the formula is y is equal to 4ac minus b squared over 4a. So we can now do the substitution. So we have our 4, our a is 2, our c is negative 5, minus our b is positive 4 squared over 4, then our a is 2. So we can now multiply 4 times 2 is 8, times 5 we get negative 40, minus 4 times 4, that is 16, over 4 times 2 is 8. So now we can add the numerator, negative 40 minus 16, we get negative 56 over 8. 8 into negative 56 is just negative 7. So this is our, so in form of the pair, the turning point for this function, the turning point is negative 1, comma, negative 7. Now let's also look at another way in which we can find the y coordinate of the turning point. Now for you to find the y coordinate, make sure you have this x coordinate. So now we can just use the original function. So the original function is equal to 2x squared plus 4x minus 5. So now what we are going to do is, where there is x, we are going to substitute with the x coordinate of the turning point, which is negative 1 squared plus 4, negative 1 minus 5. So here we can see that negative 1 squared is positive 1 times 2, we get our 2. Then negative 1 times positive 4 is negative 4 minus 5. Then from there we can see that 2 minus 4 is negative 2 minus 5, that's negative 7. So this is another way in which we can find the y coordinate of the turning point. Then also from this point, the pair of coordinates, if the question was also maybe for us to find the axis of the symmetry, so the axis of the symmetry, this is given by the x coordinate of the turning point. So the axis of symmetry is just negative 1. So axis of symmetry, you just get the value of the x of the turning point. Now for the value, since here we are dealing with the minimum value, now the minimum value of this particular function is just the y coordinate. So the minimum value here is negative 7. So in summary, we can say the x denotes the axis of symmetry, while the y denotes the value, whether minimum or maximum. Okay, now let's have another example. So we are going to answer it the same way we did. So we are just going to use this function. So f of x is equal to negative x squared minus 2x plus 24. Okay, so now what we are going to do is, the first step is we identify a. So a is given by the coefficient of x squared, which is negative 1, Our b is just the coefficient of x, negative 2. Our c is 24 here. So now the first question that we are going to answer, this first question that we did from the previous question: will this function have a smile or a frown shape? So you can pause the video and try to work this one out. So what do you think? So we are going to answer by looking at the sign of the value of a. So our a here, we can see that this time the value of a is negative, so we are going to have a frown shape. So we are going to have the frown shape. So we are going to say this function will form a smile shape. Sorry, will form a frown shape. Because the value of a is negative. Then we can look for b. We say will this function have a minimum or a maximum value? So we can say this function will have a maximum value. So we'll have a maximum value because the value of a is negative. Or maybe we can just say a frown shape has a maximum value while a small shape has a minimum value. Now from there, let's also now calculate the coordinates of the turning point. So we say we begin with the x, which is x is equal to minus b over 2a. So from the values of b, we can see that the value of b is negative 2 over the value of a is negative 1. So negative times negative 2 is positive 2 over negative 1 times positive 2, that is negative 2. Our x is equal to negative 1. So let's find our y. So y is equal to 4ac minus b squared over 4a. So the value of 4, our a is negative 1, our c is 24, minus our b squared here, so over 4 times negative 1. So 4 times negative 1 is negative 4 times 24 is 96, minus negative 2 times negative 2, that's positive 4, over 4 times negative 1, that's negative 4. Then we can add the numerator, negative 96 minus 4 is minus 100, then over negative 4. So we can divide. We can see that the value of 4 is 25. Let's also find it using the equation. So the equation is y is equal to negative x squared minus 2x plus 24. So from the x coordinate of the turning point, we have negative 1. Negative 1 squared minus 2 minus 1 here, 24. So we can see that here is negative 1 times negative 1. Then here we are going to have plus 2 plus 24. So you can see that negative 1 times negative 1 is positive 1 times negative 1, that's still negative 1. 24 plus 2, that is 26. Then here we can subtract 26 minus 1, that is just 25. So we are able to see that we are able to get the 25. So therefore, the pair of coordinate for the turning point is negative 1, 25. So here the axis of symmetry is -1. Then the maximum value is 25. Okay, so now in most cases, whenever you are dealing with a round shape, or whenever you are dealing with a maximum value, the y-coordinate will be a positive number. While if you are dealing with a small shape or a minimum value, in most cases the y-coordinate is negative. That's it for this video. Thanks for watching, and don't forget to share with friends and families.